we're going to be looking at today is translations. We're going to start off with taking the function absolute value of x and performing a couple of basic translations and stretching, compressing, that sort of thing on it. It helps if you have some of the previous notes related to what the general rules are, but we'll be reviewing them as we go along. So let's begin. The first task is to translate this function 2 units up. Now, if we're moving in the vertical direction, it happens outside the function. So up would be addition. Everything outside the function is what you see is what you get. So my new function would be g of x. That's what I'm going to call my translated function. I keep the absolute value of x just where it is, and I'm going to add 2 units to the outside in order to shift this whole thing up 2 units. Now, as a point of comparison, if I had written, say, h of x is equal to the absolute value of x plus 2, and then close my absolute value bars, this is not 2 units up. This would be 2 units plus, it's inside, so I think it's on the opposite direction what it would be. This would be 2 units left, which is a different result. And notice the difference between the two statements. 2 units up is outside the absolute value bars for my parent function, whereas 2 units to the left is inside the absolute value bars compared to my parent function. And we always work back to that basic parent function. Where did it begin? And then we can talk about where it ended. Next one down the list says reflected over the x-axis. So that means that I'm going to be taking whatever this function is, I'm going to be flipping it down. So I'm going, for every value that would be, if this point is right here above the x-axis, I'm going to send it to the exact same spot below. So maybe I have this point here, I'm going to send it down there. So that means that all of my y values are going to be multiplied by a -1. All of my outputs are going to be multiplied by that -1. Another healthy reminder, since this is a vertical change, over the x-axis means I'm rotating around that x-axis. All vertical changes happen outside the initial function. So in this case, my g of x would be negative absolute value of x. So I'm going to find the absolute value, but now I'm going to be multiplying all of those outputs by a -1. And again, let's contrast that. If I were to talk about h of x as the absolute value of negative x, this would in effect be rotating it or reflecting it over the y-axis. It's inside my function. It's inside those absolute value bars. That would result in a horizontal move, where a -3 would give me an output that normal +3 would, and so forth and so on. Now granted, these give similar results. For example, we know that absolute value strips the sign off whatever's inside there, and so you could argue that this really hasn't changed anything. And perhaps this is not the best example to that. This is still how I would write that flipped over the y-axis. Now the answers to the actual questions on our note page, of course, are going to be my g of x here and my g of x there. Let's look at a couple more examples. Our next set of samples, we're still again working with the absolute value of x. It's going to ask us to translate 3 units to the right. Now, right-left, that's a horizontal change. Horizontal changes happen inside the function itself, whereas up-down is vertical changes, they happen outside the function. As we talked about before, shifting 3 units right-left means inside my absolute value bars, I'm going to be affecting that change. So this will be my g of x. Now, since it's inside, I'm going to do the opposite of what I would expect. We usually think of right as positive, left as negative. However, since it's inside that parentheses, I'm going to do the opposite of what I would normally expect. I'm going to call it minus. Another way that you might survive this is simply to memorize the rule. For example, I memorize If I see a minus sign inside, that's to the right. A plus sign inside, that's to the left. A plus sign outside, that's up. A minus sign outside, that's down. Vertically stretching by 2. Well, now I'm out and out telling you we're working in terms of vertical. So again, that's my reminder that it's outside the function. So in this case, g of x would be 2 times the absolute value of x. So again, that's outside there. Last but not least, I've got horizontally compressed by 1/2. Now we know that horizontal means it's inside those parentheses. And since everything's horizontal, it's the opposite of what I would expect, I'm going to flip this fraction. So my new function is going to be g of x equals the absolute value, flip it, so 2x, and now I can close my absolute value. And what this is going to effectively do is mash this whole thing together. As I put my values in here, I put in 5, for example, it's going to result in an output as though I maybe put in 10. So I get a much higher value faster, which mashes the entire thing together. Again, since it's a horizontal change, horizontal changes are inside my function, whereas vertical changes are outside of it, and it's always the opposite of what I would expect. A horizontal translation, right, we normally think it's positive, but here it's negative. Horizontal compression, it says 1/2, so I flip it as 2/1. As we do more of these examples, these rules become more and more clear, and they'll match with your practice sheet where you have all the major rules written down in one place. The key is to know those guys inside and out. That makes these a heck of a lot easier to do. Let's look at some more problems in our next set of examples.